Welcome back, grade 11s, or perhaps welcome, and this is your first video you're watching. We're going to go through this diagram as the example just to see some things. You may or may not watch the full thing. You may pause along the way and say, that's enough for me, I've got it. Or you might want to watch through to see how it goes. Remember, always have your diagram there so that you can scribble in it and make your notes as well. Okay, so first things first is always to read through this to make sure that all the information that's given is in the diagram. So A, B, C, D are points on the circumference. Okay, so hidden in that already is a bit more information. So as I find the right pen here, think what other information is embedded by the fact that A, B, C, D are points on the circumference. A, B, C, D are points on the circumference. Cyclic quad, right? So already opposite angles are cyclic quad, maybe exterior angle, I don't see one. But that's already a bit of information. Also tells us, well, perhaps they're going to be angles in same seg. I'm not sure if there are any here, to be honest. Wait, A and B, A and D. No, but these are things that might be hidden, so you might start seeing those already. Okay, enough waffle there. Let's see what else we can find. O is the center. Okay, well, if O is the center, there's definitely going to be some information hidden there because you might have angle at centers, twice angle at circumference. You might have, perpendicular from center to midpoint chord, right? The center gives us quite a few things. You might have some radii. In fact, I see some radii already. So I just want to jot them down. Where's my... wish I could get to these a bit quicker. So, there's a radius, so there's an isosceles triangle. So what you might want to do is, now already, I can see that D3 is X. So I'm going to pause on reading this because I just want to capture that. It's already something I can see, and I'm probably going to use it later. So I want to put X, but I want to make sure I've got my reason there. So D3 equals X because of that isosceles triangle radii. You might prefer to read all the information and then start jotting things down, but that's just already there for me, so I kind of want to get it down. And then I might say, well, O2 I can work out as well in terms of X because it's 180 minus 2X because of angles in a triangle. So I'm actually going to get distracted a little bit. There's enough that we're going to have to do that it's probably worthwhile getting into the diagram like this. Equals 180 minus 2X. Because of some angles in triangle, and this one here must be 2x, either exterior angle or sum of angles on straight line. So O1 equals 2x, and I'm going to use exterior angle of triangle, but you could of course have used angles on straight line. Okay, enough distraction. Oh, don't rub that out, we need that. And those are probably going to be useful things though. So let's see, COE is a straight line. COE is a straight line. Otherwise, we couldn't have used angles on a straight line or exterior angle, such that E lies on AB. Okay, again, telling us that AB is a straight line. A lot of just information that's being confirmed. DC equals BC. Okay, so there's another isosceles triangle over here. So I'm going to highlight that isosceles triangle. I'm going to rub it out almost straight away, to be honest. But there's those two are equal. And there's an isosceles triangle. Okay, so it may or may not be useful, but what it has suddenly shown me is an angle at center and an angle at circumference. Okay, so that's probably going to be useful. So to be honest, I'm just going to jot that down. So again, it's just so exciting. There's so much in the diagram, isn't there? So this one here, if that's 180 minus 2x, B1's half of that. So that's just 90 minus x, right? Angle at centers, twice angle at circumference. We started from D and C to get to both of those. So let's just jot that down because what we'll probably find is that we're slowly but surely answering the questions that are asked anyway. So B1 equals 90 minus x because the angle at the center is equal to 2 times the angle at the circumference. So much better writing it here instead of, look, not as much of a scribble, right? Okay, so I'm going to rub that out. And I've got the advantage of rubbing out. Think about how you're highlighting or working with your pencil on the diagram. Okay, and what else are we told? C1 equals x. Okay, so this was given as x. So everything we're finding in terms of x. We don't know what the exact value is. But now there's one other thing that we can see maybe. No, I can't see anything else just yet. So let's have a look. Determine the size of B1 and C2 in terms of x. B1, okay, well B1 we've already got, right? So that was easy enough. 90 minus x. So part A has already been shown. So if you want to, just in terms of capturing this, you might go, well, I'm going to maybe start with A over there, or A. If we read our statements and reasons in order, we can see how we're looking. Okay, now we need to find C2. Oh, it's a pity we didn't just have C2 already, right? So C2 is over here, and we need to think, where's C2 lie? How are we going to find? Now, it's a pity. The first thing that I would look at in this diagram, and maybe you've seen it already and you wish you could just stick your hand up and say, this is how I found it, is that we could kind of work backwards to get to B, and backwards, but we don't get to the circumference. So unfortunately, there's no nice angles in same seg or angle at center. Okay, C2's in a triangle, so it's in a few triangles. So maybe if we did that working backwards, we could go, well, it's over there in that triangle, but we don't know this angle F2. What else could we do? Well, we could go into this triangle. Well, we know even less about that triangle, so that's not going to be useful. We've used our isosceles triangle, and let's see what else we can find. Well, I'm looking at this isosceles triangle that we saw earlier. Let's just show the one that I'm looking at here. DB, that. So that isosceles triangle, we didn't yet use the idea that this line equals this line, which means that B1 equals D2 and 3. Oh, that could be handy. Let's just jot that down here. To change there. So this angle here we can work out. So that angle, well, this angle D2 and 3 must equal 90 minus x. We've already got x, so we're going to need to add, let's just rub that out there, 90, and we're going to have to subtract 2x. Let's just check. Is 90 minus 2x plus x, that should equal the other angle, 90 minus x. Yeah, it does. So that angle D2 is 90 minus 2x because of that isosceles triangle. Right, let's just capture this. Now, you may have gone a different route as long as every statement has a good geometric reason and you've gone in order, then we're good to go. So that's 90 minus 2x, and I used that isosceles triangle DBC. You don't have to say which isosceles triangle you're using, but that does help clarify a little bit. So I can rub that out, and I'm going to rub, well, let me not rub out that triangle just yet, because that's probably going to help us find C2, because in the triangle itself, all the angles must add up to 180. So let's do that. So let's find out C2 by working all of those angles. We've got 90 minus 2x plus x plus x plus 90 minus x. And we need to see what more we need to add to get to 180. So we've got 90 minus 2x plus x plus x plus 90 minus x plus C2. Maybe I'll put that as C2 will give us 180, because angles of a triangle add up to 180, right? So actually, maybe we'll just put that statement here. Maybe I could move that. I always try and get it a bit better with these things, right? Oh, look at that. And you could do that with pen and paper. So that equals that because of sum of angles in triangle. Well, 90 plus 90 is 180. So the 180, well, let's just capture that. 180 minus 2x plus x, well, that is just 0. And we've got minus x plus C2 equals 180. You may have done this in your head or in a slightly different way, but this is the way I'm thinking through. So it looks like C2, well, 180 minus x plus x would get us back to 180. So C2 equals x. Try and work like that instead of going plus x minus 180. So that just equals x. Now, note that they ended up being the same. We couldn't assume that EC bisected angle DCB. Okay, that felt like a whole lot of work, and maybe you had a quick way to do it, but we had quite a lot of fun along the way, didn't we? Okay, so there's C2. We've got x. We've got lots of our angles now in terms of x. which is probably going to help us in the next question. So for our second question, show that AEOD, okay, is a cyclic quadrilateral. So what can be quite useful is, let's just highlight this part so we see what you're looking at. AEOD is a cyclic quadrilateral. Okay, so to do this, remember there are a few ways. The one is to go, let's draw our cyclic quad and see if we can show that opposite angles add up to 180. So either those two or those two. Or perhaps we need to show that the exterior angle is equal to the opposite interior angle. So if we could find A and show that it's 180 minus 2x, or there's another exterior over here, if we could show that this angle is equal to this angle. Or we could show angles in same seg, but there are no angles in same seg without a construction, and I don't feel like constructing. So let's draw this in here, and I'm going to just draw it in a bit neater. So we've got it nicely for reference and say we're looking for this cyclic quad. Now you could try draw a circle through these points and go, okay, your circle looks something like that. I'll be very impressed if you draw those circles. My circles end up looking like ovals if don't have. But there's kind of what we're trying to show, is that there is a circle that goes through. But that feels more confusing, to be honest. So let's rub that out and have a look. AEOD. So we need to show, if we could find out what A is, we'll be sorted. And hopefully A ends up being 180 minus 2x. So let's have a look how we can find out what angle A is. I'm just going to get my pens ready here and have a look. By perhaps we're looking at A. Okay, so what my trick earlier that I said was, let's look at A and let's kind of work backwards. So where's my shape here? That's what I wanted. Whoopsie. And say, okay, for A, if we kind of went backwards, not with a circle, and said, let's retrace our steps to find angle A, we get to D and B. Can we create another angle from D and B? Well, we can if we went to the opposite side of the circle. Okay, well, I've just traced out a cyclic quad. Well, what do we know about opposite angles of a cyclic quad? We know that they add up to 180. So there we go, looking at that, highlighting, maybe that's useful. Angle C, the whole of angle C, is 2x. So therefore, the angle A here must be 180 minus 2x. Okay, well, let's capture that, because we needed to find out what angle A was. So angle A, I'm going to do it over here, so we're in part B. Angle A is 180 minus 2x. Our reason for that, opposite angles of cyclic quad. Right, it's the opposite angle from angle C1 and 2. And now that we have that, and I'm just going to capture that so you can see which cyclic quad I'm talking about. I'm talking about ABCD. So opposite angles of cyclic quad ABCD tells us that if that's 2x, this angle here must be 180 minus 2x. Now if we look at the cyclic quad we're trying to prove, I don't know. Oof, perfect. Okay, well, now we're done, because angle A equals 180 minus 01. We've shown that in the pink quadrilateral, AEOD, that the opposite angles are supplementary. Okay, well, then we're done. That's everything we need to show. So, let's show that and say that, therefore, this one, AEOD is cyclic quad. And our reason for that is because we've shown that the opposite angles of our cyclic quad are equal. And we're just going to put that magic word converse in front. So converse opposite angles of cyclic quad. We've shown the opposite angles to be supplementary. Therefore, it is acyclic quad. Okay, there was quite a lot embedded in there. We had a lot of fun with that diagram, and I'll maybe see you in the next one.